Hi friends, in this video you are going to learn about grooving. Grooving is the process of making a long narrow cut or indentation in a surface. There are two types of grooving. One of it is Od grooving, another is ID grooving. That's the profile of Od grooving and this is the profile of ID grooving. And this is the grooving tool we have. You can see the grooving insert. And now we are going to perform Od grooving. We have a small profile here, so we are going to perform this grooving operation in our software. So you can see, so we are opening 8 software and starting the basic lathe with the driven tool. If you want, you can also create a new machine for you. You have to select 8 basic lathe with driven tool and click next. These are the description and the machine name. You can also edit the machine name and the machine will be created for you. So click on it and click start. Then the machine will be started for you in a few seconds. The machine is being started. It takes 2 to 3 seconds. This is the machine interface and this is the reference of the machine. We have to check whether it is in the reference or not. And this is the MDI mode. First of all, we have to send the tool to the homing position and we have to see the feed start and spindle start. Click OK. And we have to create a program now for grooving. So I am going to part programs and click new and creating a main program file of any name. I am just giving grooving or anything. I was giving Od grooving. So after you give the name, click OK. You can see the program will be created of MPF file Od grooving. So first of all, we have to take a blank, and this is the header of the program for grooving cycle. This is the header of the program, and G18, G54, G64, G71, G90, G95, these are all safety codes. G18 means X jet plane selection, and G54 means work offset, and the G64 means continuous path, and G71 is the per spindle revolutions the units, and G90 is the absolute dimensioning, and these are all the safety codes. And the G75X0Z0 is the homing position of the tool, and after that we have to select the required tool, and the M06 is the tool change at homing position, and this is about the spindle, and this is the safety points. After safety points we have to mention the coolant, and this profile now we are going to create. So I think header is clear for you, and that is the approach point. So here we have the approach point here, so we take that approach point. So this is the grooving cycle. You can see in the software, 8 software. This is the small screenshot of it, and this is the footer of the program. After we perform the program, we have to stop everything, and we have to send the tool, and we have to off the coolant, spindle stop, and we have to end the program. So this is about it. Now we come to the software. As I said, we have to first of all take a blank of required radius XA. So we have to check the radius. So it is having 100, diameter 100. So we have to give 100. XA, we have not performed any facing operation, so XA is 0, and ZL considering with clamp is minus 120, and without considering the clamp is minus 100. So next we have to come to the header, and under header, this is the header of the program, and under header first we have safety codes. So those are G18, G54, G64, G71, G90 and G95. These are all the safety codes. And next we have to send the tool to the homing position. So we write G75 X0 Z0, and after the tool is in homing position we have to take the required tool. So go to the select tool and select the tool you need. So we need a plunge cutter, so we have to mention the length and X and Z as -100 and -100, and in the machine we have to set the work offset. This is the rough work offset in the machine, and the radius is 0.8. So D1 and M06 is tool change at homing position, so we have to change only in the homing position tool. And this is about the spindle. G96 means constant cutting speed, as I said, and S500 is the spindle speed and the limits for the spindle, and M03 is the direction of the spindle in clockwise direction. So next is the safety points. So as we will not touch the workpiece, I can come in the rapid motion. So G00. So you can see that motion from here. We have to take the safety point up to there. We should not touch the workpiece. So I was giving X50 Z1, and next before touching we have to on the coolant, and the approach point is there. So G01, X50 and Z0. After the approach point we have to mention the feed rate. So I was mentioning feed rate as 0.3. Now we have to add the grooving cycle for performing grooving operation. So we have to go to turning, groove, and we have to select the groove required. We have three different types of grooves. You can see in the picture clearly. So we need a first groove. So I was filling the cycle here. So first is safety distance. I was giving just 2. You can give the safety distance as you like. And the feed rate is 0.2 I was giving. And these are the symbols of roughing, finishing and all. These are the symbols. This is roughing plus finishing. So roughing and finishing operations take place here. So next is X0, the point where we need starting point of the groove. So here is the starting point of the groove. So that is in the Z direction -18, and X is 50. -18. So I was just considering the radius, not the diameter. And next the end point of the groove is -42. So -42 plus -18. So it is it's the length of the groove. So I was giving just 42, not that. So it is the length of the groove is 42. So I was giving 42. So this is the groove, you can see. And now it is asking the width of the groove. So we have to measure it carefully. So the width of the groove is, and this is the width of the groove is 5, and this is the depth of cut. So 11 mm will be removed by giving 1, and this is the finishing allowance UX and UZ. I was leaving 0.5 material for finishing, and this is the number of grooves. So we need only one groove. So click accept. This is the grooving cycle, you can see. So after that we have to retract the tool. So G01, X55 and Z -118. So we have retracted the tool from the workpiece. So you can see the profile. If the tool touches the workpiece, we can't come in the rapid motion. So we are giving G01. After that we will give the footer. Footer is important to end the file or the program, to end the program. G75, we should, after retracting the tool, we have to send it to the homing position for the next operation. So I was sending the tool to G75X0Z0. It is the homing position, and we have to enable the cutting speed, constant cutting speed. It is G97. M05 is the spindle stop, and M09 is the coolant off, and M30 is the end of the program. And next we have to renumber the program, and we have to click simulation. After that, your program will be simulated here. You can see the groove clearly. It is the 3D view. You can see the groove. It is being cutted. You can see it clearly. The groove should be according to the program. It cuts the groove, and this is the how to make the operation, and this is the total time taken, 1.31 seconds. And thanks for watching the video.